Hello and welcome. Let us now move to the next library, that is Numpy. Numpy stands for numerical Python and is a fundamental numerical computing library in Python. It provides support for large multi-dimension arrays and matrices, along with collection of high-level mathematical functions to operate with these arrays. Numpy core structure is ND array. That is, it may be 1 dimension, 2 dimension, or 3 dimension. And here is a simple representation of that. We have a 1D array, that is, it's only, let's talk about X. We have 10, 15, 13, 8, and 25, but in a single line. Then we have a 2D array, that is, we have X and Y, and this is a matrix. We have columns and rows, and this is a 3 by 3 matrix in this case. Then we have a 3D array, which has X, Y, and Z in the Cartesian plane. We have the first dimension, the second on this side, and third dimension. That's what we mean by saying it has an ND array. The maximum we can go is 3D array. Importation of Numpy is as simple as any other library in Python or package. We have import Numpy as NP, and it's always a good practice to use Numpy together with pandas because they are somehow related, and most of the function we apply in Numpy are also applicable in pandas, or they interact in one way or the other. We just have to let us restart this kernel and run all the cells. I forgot to tell you about this. If you want to know whether your kernel is operational or it's working, you look at this. You can see the blinking. It means that some code are still running, and when it's done, it becomes white. I would like to run this again and clear all the output so that we can start anew. Basically, Numpy helps in creation of mainly matrices, and importation is simple as other packages in Python. Let's start with that by running this cell, the first cell. It means we have imported our package, and we can test to see the version. We are using Python version 3.10.11, and Numpy version is 1.24. And let's move direct to data types in Numpy. Numpy has several data types, and one advantage of Numpy and pandas is that they have they kind of have more data types than Python. And these data types include Boolean, integers, and we have the description of each of these data types. We have more than, let's say, more than 10, 15 data types. And it's always a good practice. I would like to specifically point at complex data type, which support the complex numbers in mathematics. Let's move forward and see how we declare all define arrays. Here we are creating an array which we initialize as ARR, and its values are 1, 2, 3, and data type is F4, that is float. Note how we define an array is NP for Numpy, then we define it in and we specify the data type we're using. In this case, we are going to run all these arrays. We have array 1, array 2, array 3, and on printing them, we have the first one. This is float 32. The second one is a complex, and the third one. Then we also have the string data type, which basically means it's not numerical. In the first case, we have A, B, C, D, E, F, G. And on printing this, we have the output. Next, let us look at how to create arrays using Numpy. As explained earlier, we just use numpy.array and specify the array we wish to have. Let's print this. We have an array of numbers from 0 to 9 using the range function in Python. And then let's look at this. The second array, we have numbers 1 to 5 in square brackets. That's our second array. We also can create arrays in specified data type by defining that data type. In this case, we have defined the data type that we want our arrays to be. This is an integer, and we can create array based on the range function instead of array. Create this array. We are starting from 0 to 20 with intervals of 2. Note that we can change this, let's say 3, and our array changes. Can change that to 5, and it changes to the intervals. We can create arrays based on intervals. We can also change this to 3. We'll have a 0. Let's say we change that to 50, and we have 10 numbers from 0 to 45. In this case, we are using the arrange function in Python. We can also create arrays, even in space numbers, specified interval, just as above. And the function is start, where we want to start, where we want to stop, and then number of elements. In this case, we are using the line space function. We also have other parameters. In our case, we'll start at 0, stop at 10, number of elements 20. Basically, what you want to do is create an array with random numbers from 0 and down, excluding the endpoint. In the line space, we'll have an array of this type. Endpoint false. You can also that is true. We have a decimal point. Then if it's false, we don't have that how it is. We can also create arrays using the random function. We are creating array of 3 by 3. That is 3 columns, 3 rows. Using the random function, you can change these, and let's change these and see what changes in our function. You can see the number of columns, the number of rows that is changed from 3 to 4. We can also change that, let's say, to 8. Let us move forward to creating an array of zeros with a specified shape. In this case, we are creating an array of 2 by 3. All values are zeros, and they are in integer form. Let's see, we have 2 by 3, all values are zeros. We can change this to, let's say, 8, and we'll have a longer array with 8 columns and 2 rows. We can also change this to, let's say, 5, and our array become larger than before. Next, we'll look at how to create an array of zeros with the same shape and specify the data type. And here is the function. We are using 0 slash like. That's the function to create an array of the same shape and data type as given array, feeding the 0 array from above. A 0 array was that, and therefore, and we have an array 1, 2, 3, 8 by 3. In this case, our zeros become, we create an array with zeros, but like the previous array, that is 8 by 3. Let's now look at an array of 1 in given shape. So just like in the previous case where we used the 0 function, in this case we are using ones, a function that helps us create an array of ones and define the shape that we want. Our shape is 2 by 3, and we get a 2 by 3 matrix. And as usual, we can change this and our array changes. We can change this to 1 by 3 and it changes 10 by 3. Next, we'll look at how to create an array of ones with the same shape and data as the previously given array. That is, we are going to use the one like function. Just as before, our array was 8 by 3 and we have an array of ones of the shape 8 by 3. If you wanted to change this array now, the shape of the array, we have to move up to this point and change the shape to, let's say, 4 by 4 and run that. If we come back here and run this again, we'll have a 4 by 4 array with all values being 1. Next, let us look at how to create an array of arbitrary values in a given shape. In this case, we are using an empty array and the shape is 2 by 3. Empty array means all the values are 1. We have a 2 by 3 array of all values being 1. We can change these and see what changes. I'll change this again back to 1, and we can also change that to, let's say, 4. Let's move forward and learn how to create array of arbitrary values of the same shape. This array is based on the array ARR that we defined above and empty values, that is values from the same array. We can create an array of constant by feeding the constant value after defining the shape. We have a 2 by 3 array of shape 5. That is, actually our shape is 2 by 3 and the constant is 5. We can change that to 7 and we have that. Let's see what happens if we enter. And that's an error because this is not a numerical value. Let's move on. If we change that weight, we have an array of 2 by 3, all values 8. We can change this to change the shape. Let's now create an array of constant values with the same shape as an array given. In this case, the shape is defined by the shape of array ARR. And the constant is 5. We can change the constant to 2 and to change it. Create array by repetition. In this case, we define an array. This is the array. Then print repeat array 3 times. That is, we repeat that 3 times. And we have 0, 0, 1, 1. 0, we have 0, 0, 0, 1, 1, 1, and 2, 2, 2. We are using the function repeat and repeat. And in this case, we can also use this function to create the same array. Let's see, print that, see what we get here. And we are repeating that 3 times, range 0 to 3. We are repeating it 3 times, range 0 to 4 to 3. We can repeat that, let's say, 2 times. We can also repeat along specified axis. We have an array with values 1, 2, and then 3, 4. Then we can repeat the array 1, 2 along the 0 axis. And on running this, 1, 2 is repeated along the 0 axis. We can also repeat array specified number of times. And in this case, we have specified we want to repeat the array 3 times. We have our first time, then second time up there, and then that time. We can specify 4 times, or let's say even 10 times. We can repeat along specified axis. We are repeating the array along the axis of 2 and 1. We want this to be 2 by 2, and we have a 2 by 2, the shape 2 by 3. Actually, this is the shape, not this is the axis, not the shape. We are repeating that 2, 2 on each side, on each axis. We can repeat it 3 times on the first axis. Yeah, we are repeating it 1, 2, 3, 3 times, and 2 times on the other axis. And if we have 1 by 2, we have a single one. Let us move forward, learn how to create an identity matrix. An identity matrix is a matrix that has 1, 1, 1 along the diagonal. Note that in this case, we are using the I function instead of any other function like 0, 1s, or repeat. We are using the I function, and we are getting the identity matrix. And we can also use the identity function to get the same value. That is, to create an identity matrix, we can use the I or the identity function. And create an identity function with diagonal offset. Let's see, it means that the diagonal offsets from here 1, 2, 3, 4, 5. I5 k is equals to 1. Let's see what happens when it changes the value of k. Start on the second. If it changes that, we get an identity matrix without any offset. An offset means that we are starting, we are offsetting the starting value. An offset of 1 means we are going to start here, 2 means we are going to start here, and 3 means we are going to start, and 3 means we are going to start here, and the identity matrix. Then we can shift negative, we can use the negative number to shift along the columns, along the rows, that is. Here we go, we are starting at 0, 1, 2 here, that column. I can have started at 1. That means if we have 0, we have a perfect identity matrix without any offsets. So negative means we are offsetting the rows, and the positive values. Value means we are offsetting the columns. We can also extract the diagonal array or create diagonal array. And let's see, in this case, we have an array. Then let's try and extract the diagonal values. That is, these values. We want to extract these and this. We are going to extract those using the np.diag. And we can also create a matrix with specified diagonal arrays using the diag function, np.diag, and we specify the diagonal values. That's it for creating and extracting values from matrices, or let's say arrays.